Hi everyone. We come back with section 11.5, quadratic inequalities. In this section, I'm going to talk about solving a quadratic inequality symbolically. Okay. So for this symbolically, usually if you have a quadratic inequality, you're gonna let uh, the quadratic form equal to 0. In this form, for a greater than 0, in order to have two real solutions, P and Q, I mean, for this equation, right? When you consider about the equation ax squared plus bx plus c equals 0, if it have two real solutions, P and Q, where P less than Q, so then for the case that if you are looking for the solution of inequality that ax squared plus bx plus c less than 0, then you want to have the solution will be the interval in between P and Q, okay, which is like, x is less than P, and I mean greater than P but less than Q, something like that. But if you are looking for the solution for the inequalities that's ax squared plus bx plus c greater than 0, then it's going to be outside. It's going to be the interval that outside of the interval P and Q. So you can see over here. So this is the interval P and Q. But for the second one, you're gonna have like, from negative infinity to P, and from Q to positive infinity, something like that. Say this one. Okay. So for example, right, if we have the equation x squared minus bx plus 2 equals 0 that have two solutions, is 1 and 2, right? And if we want to find the solution of the inequalities x squared minus 3x plus 2 less than 0, then x is between 1 and 2, right? But if you want to look for the x squared minus 3x plus 2 greater than 0, then x to less than 1 and x have to be greater than 2. So see that. Okay, so another thing that we're going to learn is solving a quadratic inequalities graphically. If we're given ax squared plus bx plus c less than 0 with a greater than 0, and ax squared plus bx plus c are located in any x-intercept, if there are two in x-intercept, then solution correspond to x value between the x-intercept. Solutions to ax squared plus bx greater than 0 correspond to x values outside or left or right the x-intercept. And last method is solving a quadratic inequalities numerically. Right? If a quadratic inequality is expressed as ax squared plus bx plus c less than 0, okay, with a greater than 0, then we start by solving ax squared plus bx plus c equal to 0 with a table. If there's two solutions, then the solution to the given inequality lie between these values. Solution to ax squared plus bx plus c greater than 0 lie before or after this value in the table. Okay. So now let's move down to see if we have some problem to work on it. Okay, so we have example number 1 in here. So for example, number one, let me see. We're gonna identify a quadratic inequality. All right. Okay. So column A, we have 5x plus x squared minus x cubed less than or equal to 0. So for this one, you guys should remember that this is a we are determine whether the inequality is quadratic, right? So is this a quadratic? No, it's not, right? Why? So it is not quadratic because we have term, we have an x cubed term, right? You see the x cubed over here. Since we have an x cubed, then this is not a quadratic anymore. Okay, so we're gonna just move on to the next one. So for the next one, we have 4 plus 5x squared greater than 4x squared plus 5x. Is this a quadratic inequalities? Inequalities quadratic? Let's try to convert it, right? So I would like to minus both hand side by 4x squared and x. I do that, right? 4x squared and x. So I have 5x squared minus 4x squared will be x squared, and then minus x and plus 4, which is greater than 0. Okay, so remember that's for variable. I can addition or subtraction with no changing of the relation of the inequality. But if you divide, then you cannot divide for the variable. Remember that. Okay. So that's so you are having right now is a quadratic inequalities. So is a quadratic inequality. Okay. With a equal to 1, b equal to -1, c equal to 4. Okay, so let's move on. We have example 2, solving a quadratic inequality. Okay. So we make a table of values for y equal to x squared minus 3x minus 4, and then sketch the graph. Use the table and graph to solve x squared minus 3x minus 4 less than or equal to 0. And then write the answer in the interval notation. Okay. So now so this is numerical solution. Okay. So so let's start with solving. Start with make a table of the value, right? But before doing that, we we will have, let's see. So since you try to make a table of values for y equal to x squared minus 3x minus 4, I would like to check to see to find the actually the cell. So I will let y equals 0. Okay, set y equals 0. So we have x squared minus 3x minus 4 equals 0. Then I can factor this. Can I factor this? So two number multiply equal to -4, addition equal to -3. So I'm gonna say x minus 4 and then x plus 1 equal to 0. Right. When you factor this, you're gonna have x minus 4 and x plus 1. So that means you will have x equal to 4 or x equal to 1. At x is the set. So so x the set will be 4 0 and then 1 0. Okay. Okay. So now let's have a table. Right? Let's have a table. Here's x. Here's y. I can start with some. You know what? Use. Let me see. Use table. That. Okay, so let's look at this. So I have number line, make infinity to push infinity. This should be -1. I'm making a mistake. Okay, so then I have -1, and I have 4, right? So I have separate this to be 3 interval. Right? I have split it to become 3 interval, and I want to check how many interval do I have. Okay, so let's choose some test point on each interval. Say I'm going to choose before -1, I'm going to choose -2, right? And then after -1, I'm going to choose 0. After 4, I choose 5. Okay, so for x, this point, I'm going to plug into the LX. No, the interval. Let's see what happens, right? So I have f of -2 will be equal to -2 square minus 3 and -2 minus 4 will equal to 4 plus 6 minus 4, which is 6. So this is this less than or equal to 0? No, not true. This is greater than, right? So then you will not take this interval, right? What about the next interval? I have f0, which is 0 square minus 3 times 0 minus 4 is -4. and this is less than 0. That is true. Right? So this is true, then you will take this, the middle interval. Right? What about f of 5? Last interval, use test 5, right? Here 5 square minus 3 times 5 and minus 4. We're gonna be equal to, you're gonna use calculator and see, but I'm pretty sure this will be greater than 0. So let's say 25 minus 15 and minus 4, you have 6 again, and that's less than 0, not true. So you don't wanna take the interval over here. No. So there is only the interval in between -1 and 4. -1 and 4 gonna be the solution. Okay. So solution is this. Okay. Let me see. So they say we need to make the table, right, to hear the solution, but because they want we to make a table of the value. So I'm gonna make a table over here, x, y over here. Right? So we have, let's start with -2. We know that we know that at -1 over here and 4, I'm gonna have too small. 0, 1, 2, 3. And 4. Maybe I'm gonna have one more value at 5. Okay, so I know that at -1 and 4, one gonna be 0, right? So I maybe have to have another one before number 1. So -2, we're gonna get 6. At 0, we can get -4. At 1, we can get -6. At 2, we can get -6 also. At 3, we can get -4. Let me see. At 1 is not F6. I have to check. At 1, one square minus 3 minus 4 is F6. Yeah. So it's 6, -6. So there is a vertex in between 1 and 2 over here. Okay, so 5 will be 6. Okay. So even when I grab it, I will have, say here, grab, and there's -1, 2, 1, 2, 3, 4. Oops. 4 here. And then, let me make it smaller. So maybe 1 here, 1, 2, 3, 4, 4 here. And then 1, 2, 3, 4, 5, 6. -6, -7, so -6 here. At 1, I have 1 point over here. At 2, I have another point over here. At 0, I will get -4. All right, so here. At -1, I have 0. So here at -2 I have 6. Okay, so 6. 1, 2, 3, 4, 5, 6. So I have 1, 2, this right here. Okay. Vertex should be somewhere over here, but I can't, you know, go ahead and draw it. Oh. So look like that. Another one here. Not very nice, but let's see. Okay, so there is right we are looking for, and the one that we want to find the solution which is let me see, less than or equal to 0, right? Less than or equal to 0. So we mean the red one only. So we don't want to use. So because we want to find the one that less than 0, so then x should be in this interval from -1 to 4, right? Because from -1 to 4, the graph is under the x-axis. See that? Okay. All right. So let's move down to number 3, solving a quadratic equation. So they want to solve x squared greater than 1, and then write the answer in the interval notation. So in here, we can write the x squared greater than 1 as x squared minus 1 greater than 0, right? And then, you know, you can factor this, right? You can factor this as x minus 1. Actually, you can okay, so let's factor it first. X minus 1 and x plus 1 greater than 0. You can factor like that, so that's fine. Now, in order to solve this inequality, you can take a look at the take a look at this one, right? You can go by symbolically or graphically or even numerically. That's fine. But anyway, let's go back, you know, symbolically in here. You can set x I'm going to say check x minus 1 x plus 1 equal to 0. That's give me two solutions, which is x equal to 1 or x equal to -1, right? So I will have number line. Negative infinity, positive infinity, -1, and then 1. And again, this split to become 3 intervals, right? So you will have check. Maybe I had to write this one on the top here. Better. We're gonna check some. We're gonna test some point. So before -1, I'm gonna test -2. In middle 0. After 1, 2. Right. So I have. I will test for f of -2. What do I have? I have -2 square minus 1. What is that equal to? I have 4 minus 1 is 3. And this is greater than 0. That is true. Okay, so I take the interval in, I take the interval from negative infinity to -1. And what about f of 0? I have 0 square minus 1 equal to -1. Is that greater than 0? Not true. So since it's not true, I will just, cross this one. I'm not going to take this one. And then I check the last interval with f of 2 equal to 2 square minus 1, and that's also equal to 3, which is greater than 0, and say true. And since it's true, then I'm gonna say, oh, this interval is from 1 to positive infinity, and a union to this interval. And if the question say write the answer in the interval notation, so then this is gonna be the answer. Right? Okay. So now let's move to example 4, solving some special case. So x squared plus 1 greater than 0. What happened for this one? I know that x squared plus 1. You know that x squared is always greater than or equal to 0, and plus 1 is going to be always greater than it's always greater than or equal to 1. So that's always true for all value of x. So and also if you want to graph this one as a sketch, right? You should know that it will be above. It's the vertex was 1 over here, right? And it should be just become an like concave up, upward, open upward parabola. So just go up to the positive infinity from 1. So so you will say the graph is always above x-axis. So x squared plus 1 is always greater than 0. And since it's always greater than 0, then so solution set is from is Oreo number, or from negative infinity to positive infinity. Okay, so you're gonna have solution set is Oreo number, or from negative infinity to positive infinity. Any. Okay, so now let's see. For x squared plus 1 less than 0, you can see the graph of this is just part A, but now it's want to ask if is there any way to make the graph is less than 0. So you can see the graph over here is never below, right? The graph is never below like this, right? So I'm gonna say the graph is never below, because what we need is below. What we need is below x-axis. So okay, so the graph is never below x-axis. So then x squared plus 1 is never less than 0. Since it's never less than 0 though, so no solution. No solution. Okay, so then there is no, oh, I'm gonna say no real solution better. Okay. No real solution. Yes, no real solution. And I'm gonna say, okay. For part C, okay, part C, because the so let's see what about this graph. If you wanna if you know how to graph like x minus 1 square. Actually for this one I have to write it as y equal to x squared plus 1, right? Let's sketch say let's sketch y equal to x minus 1 square, right? And see what happens. So we have move to the right x, so x squared move to the right underneath, so here and then right and then right. So you can see that the graph is also going up and never below x-axis, never go below x-axis. Okay, so I'm gonna say the graph never goes below x-axis. So x minus 1 square never less than 0. However, okay, but at x equal to 1, we have y equal to 0. We make is only solution to the inequality. Okay, so you can see over here at this point that make x minus 1 equals 0. So I have solution is x equal to 1 as an answer on. Yeah. Because this one include the equal, okay? Include the equal. So that I have to take the k that make the graph equals 0. Okay. Down here is some case for solution of the inequalities you should consider. So for the first one, case number one, with upward openings parabola. For this case, I have in here is y equals to x squared plus x minus 2. Is has two intersect, two x intersect, and that will give me for x squared plus x minus 2 less than 0 for and get the solution as negative 2 at x in between negative 2 and 1. Let me see over here. And if I want to look for the case that the graph is greater than 0, then we will look at the interval that make the green line, right? The green one. So that is x less than negative 2 or x greater than 1. So case number 2, same one, but now become downward opening. So which is negative x squared minus x plus 2. And if we are looking for, like, the two solution for x-intercept, so that's going to be negative 1 and 1 over here. If we're looking for the graph less than 0, which is a red line, then the interval going to be from x less than negative 2 or x greater than 1. For the case that want to look for the graph greater than 0, which is a green line, then it's going to be in between negative 2 and 1. So similarly, you can see for the next two case, you will have one solution or one x-intercept, right? See that? And there is no solution if you look for less than 0 at the first as case 1 here, and greater than 0 at the case number 2 here. And for no intercept graph, you will have no solution when you look for the x-intercept, right? You also want to get no solution if you want to look for the x squared plus 1 less than 0, because the graph will never below the x-axis with that. And all remember for greater than 0. And opposite, for the case number 2, you will have all remember for look for the graph less than 0 and no solution for greater than 0, right? Okay, so now we're gonna talk about solution to quadratic inequalities. If I less ax squared plus bx plus c equals 0, with a greater than 0, have two real solutions, p and q, like I say above, right? As with p less than q, you have ax squared plus bx less than 0 is equivalent to p less than x less than q. Remember that in this case less than 0, right? And for greater than 0, then you're going to have x less than p or x greater than q. Okay, so also for the quadratic inequalities that involving less than or equal or greater than or equal can be solved similarly. Okay, so now let's move down here and see how I solve this one. Okay, so remember that in here I have a equal to 6, which is greater than 0. Okay, so I can I can let 6x squared minus 7x minus 5 equals 0 and solve for this one and see what do I have, because I want to find P and Q, right? Remember that's, can I factor this one? I need to see if I can factor this one, right? So I would think about AC method. So A times C equal to negative 30, B equal to negative 7. So two number that multiple equal to negative 30, that addition equal to negative 7. I'm gonna start with 3 and 10. Okay, so I have 3 and negative 10. Okay, but remember that A in here is equal to 6, which is not a special case, so I have to convert the middle term to become two terms. So I have 6x squared stay, and I'm plus with 3x and minus 10x and minus 5 equals 0, right? You see now from negative 7, I change to become two term. So now I factor for, I'm going to use grouping method to factor for h two term. So 3x, I have 2x plus 1, right? For the first two term, I factor out 3x. And the next two term, I'm going to factor out negative 5. So I have 2x plus 1 equals 0. And then I factor out 2x for this two big term. Then I will have 3x minus 5. And that's give me 0. So now I did factor out, I have two factor here, and I'm going to apply the 0 factor property, which give me 2x plus 1 equals 0, or 3x minus 5 equals 0. So then I have x equal to negative 1 over 2, or x equal to 5 over 3. Now I'm having a solution for the equation, but not the solution for the set, for the inequality. I'm gonna say this, x equal to negative 1/2 is p, and x equal to 5 over 3 is q, because p is less than q, right? Okay, so now according to the way to the property here, I can just make a conclusion right away instead of having number line like above here as show you, right? You can for now you can just quickly get to the solution as so greater than, right? It's greater than or equal to, so that's gonna go by this way. That's gonna be outside, right? So you're gonna have x. So the solution for 6x squared minus 7x minus 5 greater than or equal to 0 is x less than negative 1/2, or x greater than 5/3. So which interval gonna be negative infinity to negative 1/2 union with 5/3 to positive infinity. That's going to be the solution for this inequality. So the last one over here having changed to be the critical, sorry, the what's it called? Quadratic form. So I need to convert it and let's see what happens, right? So I have distribution have to be negative x squared minus 3x. No, plus 3x. And then I'm going to add with, no, just step by step. Now I'm going to add both side by 18. So I have negative x squared plus 3x plus 18 greater than 0. Okay, so what I do is I'm going to multiply both sides by negative 1. Okay, so watch out for this one. Okay, multiply both sides by negative 1. So I have x squared minus 3x minus 18 less than 0. Okay, so since it's multiplied by negative 1 for both sides of the inequality, then the direction of the inequality is going to change from the greater to the less than. Okay, so now you are having quadratic form already. So what you do is you have to, solve. Let me see. So normally, so set or let x squared minus 3x minus 18 equals 0. And then I will solve for this one. After this, I have x plus 3 times x minus 6 equals 0. Then I have x equals to negative 3 or x equal to 6. And since you have these I have to make it Q is P and x equal to 6 is Q, right? So that if you have these, then you're gonna just say solution for the inequality x squared minus 3x minus 18 less than 0 is, so since it's less than 0, you're gonna use the middle interval in between two P and Q, right? So you're gonna have like x in the middle between negative 3 and 9. Or the interval gonna be negative 3 and 9. Okay, so before doing that, I want to check with A in here. The A in here give me the inequality with the equal sign. So I have to change a little bit. I have to have equal here, and that's mean I have to include the negative 1/2 and 5/3. Then I have to then that's going to be the solution, and lastly this going to be solution of the inequality that we are having here. B. Okay, so I'm done with section 11.5, right? I will see you in 11.6 later. Okay, bye.